all. So today we will be discussing about limits, which is a very important foundational concept in calculus. So we'll delve into a crucial notion that forms the bedrock of calculus and lays the groundwork for understanding continuity, derivatives and integrals. So limit it serves as a bridge between discrete and continuous, providing us with a tool to comprehend and analyze functions in infinitesimal realm. So if we really learn about what limits the idea is all about, it captures the idea of approaching a certain point or value, even if it has never existed, even if it is never exactly reached. This concept not only enables us to tackle complex mathematical problems, but also plays a pivotal role in various real world applications, whether it is physics, economics or any other subject, right? So we'll learn about limits over here, right? So let's start with an example where let's consider a function. So if you can see on my screen, so we will start with considering a function where fx, just give me a moment. So where fx, this is equal to x square minus 1 divided by x minus 1. Now if we do it here, x should not be equal to 1 to make it a valid function, right? But what if we want to know what is the value of x when x approaches 1? So what is the value of fx if x approaches 1, right? So if we do that, if we simply put here x is equal to 1, so what will happen is, if we just see to it, it becomes 1 minus 1 square minus 1 divided by 1 minus 1, which gives us interdeterminate form 0 by 0. So we can't do that. So what we can do over here, this is completely wrong. So what we do here, we apply the limits. So how we do it? We'll say that x is approaching 1, right? So now there are two ways where we can determine, but the first thing that is that our denominator should not go to 0, right? So what we can do is, applying various things here over like various limits concept, what we will do, and we'll come to it later on, but just quoting it as an example. So limit x goes to 1, right? Or we can always say limit x tends to 1. So this becomes this function if I want to take out the value, right? So what I'll do, this is fx, right? And here I would write limit x goes to 1, and this becomes x square minus 1 divided by x minus 1. So if we want to solve this, what we can do is, we have already learned about in algebra basic classes that a square minus b square is, so we can write 1 as 1 square, right? So we can do it like this. So we'll not forget to write limit x tends to 1 over here, because we want to find the value of that, right? So here how we will do it, we'll again write here a square minus b square is a minus b into a plus b. So what we are going to do here is, we'll write it as x minus 1 into x plus 1, right, divided by x minus 1. So what we can do, because numerator and denominator has the same factor, so we can cancel these out, and we are left with limit x goes to 1 x plus 1. Now if I put x as 1, or I can always say that we'll put 0.99 or 1.01. so like that we can take x as the values, which we'll be dealing in later on. So what we can do is, here we will get as answer as 2, because we can say that yes, if we do here, because now there is no issue, if we put 1 over here, so 1 plus 1 will be 2. So we'll get 2 as the answer. right? So limits help us analyze and understand the behavior of function at specific points, even when direct substitution results in indeterminate form, as we had just seen, right? So this is a very powerful mathematical tool for examining continuity and evaluating expressions as they approach particular values, right? So as we have quoted this example, and we had seen from this example, we can definitely do these kind of things with us, right? So see you in the next video, and we will be discussing more about limits, how to solve the limits question and its various functions. Will do side by side what are its rules, what all we follow while solving the limits question, right? We'll be dealing with this in this section only, right? So see you in the next video. Take care.